Good morning, ladies and gentlemen. Today we're going to do one of my favourite reactions, which is the thermite reaction. Two really important words here. It is an exothermic reaction, meaning we're going to get lots of energy out from this reaction. We do put some energy in, so we need to break the bonds in the reactants that are there, and that will need some energy. When our products then form, that release lots and lots of energy. So our net movement of energy is from the chemical store to the thermal store, so things are going to get hot. Second word there. Displacement. Hopefully you've already seen my other video about displacement reactions. The thermite reaction is a classic example of a displacement reaction where a more reactive element will take the place of a less reactive one. So before we get into the practical, let's just analyse what's going to happen first of all. Our reactions in the thermite reaction are quite simple. We have iron oxide, rust. We have aluminium, which will be in a form of powder. So we can just put those two things together. The chemical reaction, when it happens then, if we can work out what's going to happen, aluminium is more reactive than iron, therefore the aluminium can displace the iron. So what we end up with is aluminium oxide. Can't start then. And the poor little iron gets left on its own. So aluminium oxide plus iron. If we do that as a chemical formula, the aluminium oxide is Al2O3, so 2 aluminium atoms for every 3 oxygen, and iron is Fe. And hopefully as well you'd be looking at that going, oh, that's not balanced, you need to quickly balance that. Of course I do. So let's have a quick look at this. It's quite a simple one. Over here there's 2 aluminium, so we also need 2 aluminium here. On this side we have 2 iron, so we also need 2 iron on that side. So that comes out nicely balanced. Okay, that's the chemical reaction that's going to happen. What we'll now do is wander over and actually put it together and fire this off. Right guys, so here is our setup for the thermite reaction. I'm going to talk you through what the components are and then we'll quickly cut the video and I'll come back to the exciting bit. So fundamentally, what have we got? So I've got my 2 powders. I've got, see if you can see them very clearly here. That one is my aluminium powder, so it's a silver powder, it's just powdered up aluminium. This one, the nice bright red one, is rust, it's your iron oxide, okay? So just to prove you, so most of you know that iron is magnetic, but when it's part of a compound, it is not. So here's my magnet, doesn't do anything. So my 2 reactants, they are going to go inside these flower pots. So there are 2 flower pots. Reason there are 2, with this reaction being so exothermic, when we make our iron, it's going to be about 3,000 degrees, which is quite toasty. That sudden change in temperature will basically fracture the inner one of these. And if we just have one, the sudden change in temperature will fracture it and the bits will fly off like a fragmentation grenade and I'd be in a lot of danger. Therefore, by having 2, what that means is the first one can fracture, the outside one should stay in place and contain those pieces. So the powders will go in there and I'll mix them together very well. You need to put a lot of energy into this reaction to make it go. So although you're going to get a lot of energy out, you've got to put a lot of energy in. So how are we going to set this off safely? So a couple of safety things. First of all, I am going to be wearing a face mask because if I make mine at 3,000 degrees, it sprays out and lands in my eyes, I've obviously got a very bad day. So I'm using a face mask. I'm also going to try and make sure I am nowhere near this reaction. So the powders will be in there. I'm going to have a sparkler. So I put the sparkler in the top and I can then light the sparkler and the sparkler will go down. Problem is, on its own, the sparkler is not going to be hot enough to ignite this reaction. So wrapped around the bottom of the sparkler, I'm going to have this lovely metal that you're probably all familiar with, some magnesium ribbon. Effectively, what I'm basically building myself is a 2-stage fuse. So the sparkler will burn down, it'll be sitting in there inside the powders. When it gets to the magnesium will light and that will burn hot enough that it should fire off the thermite reaction. So the aluminium will start stealing away the oxygen to make aluminium oxide and my iron. And the iron will be so hot that it will pour out the bottom as a molten stream at about 3,000 degrees. To put that into perspective, lava is only about 1,000 degrees. This is 3 times hotter than lava. It's going to be warm. That's how the reaction should go. Hopefully it all goes to plan and nobody dies. This is the plan. So I'll cut the video there and we'll come back and I will show you the reaction in place. Okay then, guys, without any further ado, let's get this reaction going. So parts of bear ready to go. I've got my fuse ready to go. I'll light the fuse. I'll then step back and hopefully you'll see the reaction. What you should see is the bright white light of the magnesium lighting, and then you should see the very, very bright light of the thermite going, and obviously hopefully see our stream of molten ions. So without further ado, alright, there goes our magnesium. And hopefully any second we'll see the thermite. Any second. And that, ladies and gentlemen, is your thermite reaction. So we can see, I'm not going to get too close just in case it spits, but you can see the glowing and all that. That is now a pool of molten iron. Was about 3,000 degrees. It's going to be cooling down very rapidly. So what I might do is just quickly stop the video there and pop back a couple minutes when it's a bit cooler, and I can prove to you that it is iron, because if it's pure iron, of course, it will be affected by the magnet. Okay. I thought I'd just quickly show you. So I've left it a good 10 minutes. Here's my magnet. Here's what came out of the bottom of our flower pot. So if the reaction has gone as it should have done, we should have here pure iron. So here's my magnet. Here's my lump of iron, and of course, lo and behold, iron is magnetic. There's some proof. So the thermite reaction, just a reminder, it's a displacement reaction. It's very exothermic, and you're turning a mixture of aluminium and iron oxide into iron and aluminium oxide. Cheers guys, see you later.